Alright, we got the history of Earth iceberg. Let's go. First up, we have Pangea. Most people have heard of Pangea, but let me paint a picture of just how bizarre the Earth looked when Pangea was real. Roughly 335 to 175 million years ago, with its peak as one unified landmass around 300 to 250 million years ago, every single piece of land on Earth, every continent, every island, everything was smashed together into one absolutely massive supercontinent. The interior of the continent was so far from any ocean that it became this massive dead zone desert, thousands of miles of arid wasteland with almost no rainfall because the moisture from the oceans couldn't reach that far inland. Think dust storms that could swallow the horizon, massive salt flats, and extreme temperature swings, scorching hot days followed by freezing cold nights like a super Sahara that stretched for thousands of miles. The weather patterns were completely different as well. Coastal Pangea didn't just get rain, it got mega monsoons. And one giant supercontinent meant one giant seasonal engine. Summers on Pangea could bring continent-scale monsoon systems along the coast that could turn dry riverbeds into catastrophic floods in a single season. And then the weather would flip and the whole region would bake into dust for months. And if you could somehow stand in the forest of early Pangea, it wouldn't feel like Earth at all. Pretty much everything looked different. You would be surrounded by these alien looking swamps filled with towering fern trees, giant club mosses, and horsetails. Nothing like the trees we know today. Then you got the bugs. In the high oxygen atmosphere earlier in Pangea's era, arthropods grew to terrifying sizes. We're talking dragonflies with 2-foot wingspans and millipedes the length of a car. The world didn't just look different, it sounded different, smelt different, and felt completely alien. And the wildlife at the time were all crammed into this one landmass, meaning predators and prey that would normally be separated by oceans were now competing in the same ecosystem. No oceans meant no barriers, so when something evolved a new advantage, it could spread across half the planet like that. And it's also a reminder that the ground beneath our feet isn't stable at all. Like, we are literally on a giant slow-moving puzzle that's constantly rearranging itself, meaning eventually in a few 100 million years, the continents will slam together again in a new supercontinent, and the Earth will look completely unrecognizable once again. Next up, we have the Permian Great Dying. Everyone knows the asteroid that killed the dinosaurs 66 million years ago. That one was bad. It wiped out about 75% of all species. But that was nothing compared to what happened 252 million years ago at the end of the Permian period. This event, officially called the Permian Triassic Extinction Event, also known as the Great Dying, wiped out around 80 to 90% of all marine species and about 70% of all land vertebrae. Let me repeat that. 80 to 90% of everything in the ocean died. This is the closest life on Earth has ever come to being completely erased. And if it had gone just a little bit further, we probably wouldn't be here today. The leading theory is that a series of massive volcanic eruptions in what is now Siberia caused the Great Dying. These eruptions were massive, covering an area the size of the continental United States with lava. And it pumped so much CO2 and sulfur dioxide into the atmosphere that it triggered a runaway greenhouse effect, basically making the Earth's conditions more akin to Venus. The oceans heated up, became acidic, and lost most of their oxygen, creating these dead zones where nothing could survive. On land, the temperature spiked, wildfires raged through ecosystems, and toxic gases poisoned the air. It took life on Earth 10 million years to recover from this, and the world that came out the other side was completely different. Next up, we have the pre-dinosaur rulers. Dinosaurs get all the credit. They're freaking sick, obviously, right? They get all the movies, they get all the museums, but they were actually late to the party by millions of years. Before the first T-Rex walked the Earth, the planet was dominated by a group of creatures called synapsids, also known as mammal-like reptiles, and these things were just as terrifying and bizarre as the dinosaurs. One of the most famous of the bunch is the Dimetrodon. I think that's how you say Dimetrodon. This is the creature with the giant sail on its back that everyone thinks is a dinosaur, but it's not. The Dimetrodon lived about 280 million years ago, and it was one of the top predators of its time. Its mouth was full of these sharp teeth with differentiated teeth, something reptiles didn't have, but mammals do, which is why it's called mammal-like. And it wasn't just synapsids either. There were also these armored herbivore tanks like the Scutosaurus, these massive creatures that looked like a cross between a tortoise and a rhinoceros. And then the Gorgonopsids, these saber-toothed apex predators that looked like a nightmarish fusion between a wolf and a reptile with these massive canine teeth. And I think the scariest part about these fellas right here is that they crawl around like lizards, not like a dog, how you would expect them to crawl around. They crawled around like this. I don't know what it is about that, but it is terrifying. These things weren't like just primitive creatures that evolution forgot about. These were highly successful, highly functioning animals that ruled the earth for tens of millions of years, and they were in their prime. But then the Permian extinction happened, and almost all of them were wiped clean, clearing the stage for dinosaurs to take over. Looking back on it, the earth really is just a series of dominant empires that rise, fall, and are completely forgotten, replaced by the next wave of rulers. Next up, we have the purple earth. Everyone thinks the earth as the blue marble, but at one point it might have been purple. See, billions of years ago, if you looked at our planet from space, it could have been a deep, vibrant purple. Before green chlorophyll became the dominant photosynthetic molecule, ancient microbes on Earth might have used a different molecule called retinol to harvest energy from sunlight. Chlorophyll reflects green light, which is why plants are green. They absorb red and blue light and bounce the green back. But retinol does the opposite. It absorbs green light and reflects red and violet, which means organisms using retinol would appear purple. And if these purple microbes covered the oceans and land masses the way algae and plants do today, the entire planet would have just been this eerie alien purple hue. Some scientists believe this purple earth phase lasted millions, possibly billions of years before chlorophyll-based life evolved and took over. Meaning if we could travel back in time and look at Earth during this period, you'll see a strange purple planet that looks nothing like the regular Earth that we know and love today. Moving on, we have the Great Oxidation event. This is actually one of the most important and horrifying turning points in the history of life on Earth. And it's also the only reason we're able to breathe right now. About 2.4 billion years ago, a group of microbes called cyanobacteria evolved the ability to perform photosynthesis, converting sunlight and carbon dioxide into energy and releasing oxygen as a waste byproduct. Which sounds good, like, yeah, oxygen, we need that to breathe and survive. But no, you'd be wrong. Because at this point, oxygen was one of the most deadly poisons on the planet. For the dominant life forms of the era, anaerobic bacteria, which thrived in an oxygen-free environment, the sudden flood of oxygen into the atmosphere and oceans was catastrophic. Oxygen reacts aggressively with organic molecules, breaking them down and causing what we now call oxidative stress. Basically, it was toxic to nearly every living thing on Earth at the time. Oxygen also reacted with methane in the atmosphere and broke it down, which caused global temperatures to plummet and triggered one of the longest and most severe ice ages in Earth's history, the Hyronian glaciation. It took me a couple tries to get that, which lasted for roughly 30 to 100 million years. The planet was completely frozen, covered in ice from pole to pole, and life barely clung on in a few isolated refuges. But as we all know, Mother Nature has a twisted sense of humor because this catastrophe paved the way for complex life. Oxygen allowed for the evolution of aerobic respiration, which is far more energy efficient than anaerobic processes, and it enabled the development of multicellular organisms, animals, plants, and eventually us. And finally, we have the giant impact hypothesis. This is the story of how the moon was born, and it's one of the craziest events in the history of our planet. About 4.5 billion years ago, when Earth was still a young molten world, a Mars-sized protoplanet named Theia was on a collision course with us. And when I say collision course, I mean a full-speed obliterating impact. A collision that melted and vaporized huge sections of both worlds. Theia slammed into the early Earth with so much force that it liquefied the crust, vaporized huge sections of both planets, and sent an unimaginable amount of debris, molten rock, metal, blasting into space. The impact was so violent that it may have helped set Earth's tilt, and the energy released was equivalent to billions of nuclear bombs going off simultaneously. For a brief moment, Earth wasn't a planet anymore. It was a molten, glowing ball of liquid rock and metal, a hellscape where nothing could survive. The debris from the collision formed a massive ring around Earth, kind of like Saturn's rings, but made of molten rock and metal. And over time, that debris clumped together under its own gravity and cooled into the moon. So next time you look up at the moon, remember you're not just looking at some random rock that got captured by Earth's gravity. You're looking at a piece of Earth itself, a fragment of your planet that was violently ripped away in a collision that really should have ended everything. We shouldn't be here right now.